Okay, this is going to be problems 1 and 2 actually on the second assignment for the week of April 20th. This is a parametric equation problem. So I was given parametric equations in x and y. The first question was to sketch the particle's path and indicate the direction of motion. I just did this on my calculator, not much to it. So just parametric equations, so you can remember change the mode to parametric. Thing starts here actually, kind of works its way over to here. You can also plot points, a little bit of a pain, but you could also go t, x, y, plot some points, a little bit of a pain. Second part of the question says, at what time does x attain its minimum value? And then where is it at that time? So two ways to do this problem. One is just to go ahead and graph this on your calculator. That's what I did. I just graphed this on the calculator and asked the calculator to find the minimum point. Graph looks something like that. So minimum point at t equals 0.618. Of course, the other way you can always find a minimum point is to take a derivative, right? Take a derivative, set it equal to 0. Either way, I thought that was a little bit easier. And then it said where was it at that point, so I just plugged the 0.618 into x, 0.618 into y, and it's at negative 0.291.73. And the third part of that question is when is it on the y-axis, and find the speed and acceleration at that time. So it's on the y-axis when x is equal to 0, x is 0, y-axis, so you take the x, set it equal to 0. Just do this on my calculator again. I guess there's my x again, right? So there's that 0 right there. It's at, where is it? 1.285. There's also one at 0, of course, but I don't really think that's the one they were talking about. That was a starting point, so I just ignored that one. So I got 1.285. It asks for the speed and the acceleration vector. The speed is the square root of dx dt squared plus dy dt squared. So I just found the derivatives. Very easy to do. Derivative of x, derivative of y. And then I just plugged in the 1.285. I squared that, or put in the 1.285, squared it, put in the 1.285, squared it, added them together, took the square root, got 1.197, and then asked for the acceleration vector after that. Acceleration vector is just another derivative. So the second derivative of x is just the derivative of this one, which is 1 plus t to the negative 2. Second derivative of this one is the negative 3 sine t. Just plug in that same time that they wanted at, 1.285. And I got 0.19i minus 2.87j. So that's it for problem 1. Problem 2, pretty straightforward. That's why I did these at the same time, be a little quicker on this. This is just some regular old regions and revolving and stuff. So the question here, you had a y equals x squared and y equals 4. First question was to find the, the area of the region. So the intersection points are at negative 2 and 2. You could use symmetry also, so 2 times 0 to 2 if you want. Top curve minus bottom curve. If I draw on the little rectangle, just 4 minus x squared. I actually did this by hand when I did it, but you can do this on your calculator, of course. So whatever the decimal value of that is fine. 32 or 3. Part B said revolve it around the x-axis. If I revolve this around the x-axis, it's a Washer method. So it's pi, same limits, negative 2 to 2. Outside radius, which is that length, which is 4, so 4 squared, which is 16, minus the inside radius, which is that length, which is x squared. 256 pi over 5, and again, decimal value is fine. If you just did that whole thing on your calculator, totally fine. And then the third part of this problem was there exists some k greater than 4, so up here somewhere. So we revolve around that horizontal line, we get the same volume as we got here. So it's just another Washer method, but it's going the other direction, right? So the outside radius becomes that length, which that's k, remember? So that's the k minus x squared. So first of all, negative 2 to pi, outside radius, inside radius, right? Outside radius is from there to there, which is just the k minus x squared squared. The inside radius is that little distance right there, which is just k minus 4 squared. And then that volume needs to be the same as that, 256 pi over 5. Didn't ask you to solve or anything like that. So pretty straightforward integrals on that one, I think. So that was 1 and 2.